right, so this question also involves kind of a similar setup, except it's not symmetrical, at least we can't assume that it is. And so I will go ahead and draw a free body diagram that I can work from. I do know the weight force pulling down is going to be 110 newtons, since I know the mass is 11. And I know this force here is 54, and I can also figure out an angle here. Since I'm given that this angle up here is 140, I can tell that this one right next to it is going to be 40 degrees. And since I've kind of got the Z shape here, then I know that this angle down below is also 40. So I've got really all I need to find the parts of that triangle. Let's go ahead and do that right away. I'm just going to call these sides A and B so I can keep track of them. So A is going to be 54 times the cosine of 40. And let's see, that comes out to be 41.4. And then my B value, I could use the Pythagorean theorem, but I'm just going to go ahead and keep going with the pattern. 54 times the sine of 40, and that one comes out to be 34.7. All right, so let's turn over to the other side of the triangle, or this other side of the picture. So this tension force that I'm looking for is pointing at some angle from the other rope. Okay, so we'll first find an angle inside this triangle, this angle here, and then we'll use that to figure out theta in a second. But we also need to find the tension force. So using the idea that the sum of the forces in the x direction are going to have to equal 0, I can say that if this is A, then this side is also A. And so I know that I know that this can be labeled then as my, what was that, 41.1. And then to figure out the other side, I know that the sum of my forces in the y direction must also equal 0. And so if that's the case, I already know that I have this value of B that's upwards, that's 34.7. And then I have this other side that I'm looking for. Let me just temporarily call it C. So those two up forces are going to have to equal the down force of 110. And so from that I can figure out here 110 minus 34.7. So that one comes out to be 75.3. All right, so now we've got this other side over here. Most of the parts of our triangle are known now, so 75.3 newtons. And so we could figure out using Pythagorean theorem that the tension force in that rope, 75.3 squared plus 41.4 squared, that gives us our tension force. There we go, which is 85.9 newtons. And then we also need to find an angle here. So again, the angle that I'm going to try to find is this angle down here. I'll use the tangent function for that. So my angle, I better not call it theta, we'll call it phi, is equal to the inverse tangent of 75.3 over 41.1. Again, that's not my final answer. That's kind of just helping me get to it. And when I plug that in my calculator using the inverse tangent, I get 61 degrees. And then I can kind of finally find that angle that I'm looking for, the theta. Theta plus 61 plus 40 is going to give me my total of 180. And so from that I can figure out that theta must be equal to, what is that, 101, 79 degrees.